two major basic concepts in trigonometry. These are trigonometric functions and the method in which one can solve for side lengths in right triangles. Okay, so let's start with some examples first. The first example, I will have a triangle in which there are the side lengths 16, x, and 40. So 40 is the hypotenuse, x is one of the legs, 16 is one of the legs. So in previous videos we have discussed the Pythagorean theorem and how that can be used to find unknown lengths. So let's use that. We would start with the two legs on one side, so a squared plus b squared equals c squared. And x, so this x squared plus 16 squared equals 40 squared. Okay, so x squared plus 16 times 16 6, 3, 9, 0. We get 256, and I will use a calculator just to make sure that I'm giving you guys the right answer. So we get x squared plus 256 equals 40 squared, so that's just 1600. Now we can subtract both sides. Okay, so 16 squared is 256, and 1600 minus 256, subtract 256 from both sides to get the value of x squared, and we get 1344. This is equal to, oops, that was a very weird 4, my apologies. So 1344 is equal to x squared. Now we want to get the value of x, so we will square root both sides, and 1344, of course we would only take the positive square root because side lengths can only be positive in this case, and we get x is equal to 8 root 21. So this is the answer to the first example. Notice how I didn't round it. The reason I did that is because you always want to give the most exact answer as possible. Unless your teacher specifically asks you to round, it's generally better to give the most exact answer. Alright, so this is the first example. We were given the side lengths x, 16, and 40, and we used the Pythagorean theorem to solve for side length x, which was 8 root 21. So now let's try another example. Let's get rid of this. Okay. Alright, my apologies. Let's go to example 2 now. So we have a triangle, and the triangle is, the sides of the triangle are x, 14, and 20. This is very similar to the other problem because we're solving for a leg. So we would go ahead and put this in the Pythagorean theorem. X squared plus 14 squared equals 20 squared. 20 squared is just 400. And 14 squared is 196. So x squared plus 196 equals 400. Now, using very basic computation, we get x squared equals 204. We take the square root. Ta-da! We get x equals 2 root 51. And again, we want to give the most exact answer. So that's the answer for example 2. 2 root 51. And now let's go to our third example, which we will be solving for the hypotenuse. So let's get rid of this. So this example will be 2, 8, and x, where x is the hypotenuse. 2, 8, and x. This is different from the other examples because for the other examples we were solving for the leg. Now we're solving for the hypotenuse. So we would put this in the Pythagorean theorem. A squared plus b squared equals c squared. So this is 4 plus 64 equals c squared. 68 equals c squared. And if we take the square root of 68, we will get 2 root 17. And I notice I put c. This is x. C is the hypotenuse, but it's x because the hypotenuse is x. So it's the same thing. 2 root 17. And that is the value for x, or the length of the hypotenuse in this situation. So that's all pretty easy. It's just basically plugging it in the equation. Now we're going to get into the trig functions, and this is very, very important in your trigonometry careers, because without knowing this you won't be able to compute a lot of the things, and you will eventually have to do many things with this, like graph them, solve for double, like sine of 2x, sine of x over 2, these sort of things. So we need to learn the basics first. Sine, cosine, and tangent. So these three trig functions have been abbreviated into a saying called so, ta, so. And I know this is probably review for many of you because this is a concept that has been established in geometry, and further you further refined the concept, mastered it in algebra too, hopefully. But if not, this is just going to be a little review because these concepts are very important. So means sine is equal to opposite. It's going to abbreviate opposite with these three letters over hypotenuse. So I'm just going to abbreviate these. Sine is equal to opposite over the hypotenuse. What would this look like? Okay. So let's say this is your right triangle, and this is your angle. If you want to find sine of theta, we would go opposite of the angle over the hypotenuse. It's very simple to calculate that. Now for cosine, it's similar to sine, but instead of opposite, we will be going adjacent over the hypotenuse. And adjacent basically means the side length that's next to the angle. And I'll demonstrate what I mean by that here. Dang, I really can't draw today. Okay. So this is your triangle, this is your angle. If you want to find cosine of theta, we're going to the adjacent over the hypotenuse. Very simple. Again, most of you probably already know this. This is just review for the most of you. And this is tangent. Tangent is opposite over adjacent. So it will look like this. It will look like this. So these are the three triangles we have shown, and these are the three trig functions, the main three trig functions that we have shown here. Now we will be going to cofunctions, which are a function's cofunction. The cofunction of a function is seen when the function is equal to the function is equal to the complement of another function. And I'll explain what I mean by that. So this is the cofunction. And if we, for example, if we have sine of theta, and we want to find the cofunction of sine of theta, that would mean the cofunction would be equal to whatever the cofunction is, the complement of the function, so 90 minus theta. And if we look to a right triangle, and let's see, this is sine, this is the theta. We know that the sine would be opposite over hypotenuse. So then what would we need? What would we need to get the same opposite over the hypotenuse? So let's just say x and y, so we can visualize it. How would we get x over y? How would we get x over y? What is another way we can do that without using sine? Well, we know that cosine is adjacent over hypotenuse. And what is the angle that's adjacent to the side length x? Would be this. We'll just call this beta. So cosine of beta is equal to x over y. And why is that so? Because it's a cofunction. Because 90 minus theta is equal to this angle. Why is that? Because all angles must add to 180 degrees. So we already have 90 out, so theta plus beta must equal 90, because 180 minus 90 is just 90. So that means theta plus beta must equal 90. And theta is equal to 90 degrees minus beta. And it's as simple as that. So what is the cofunction of sine? The cofunction of sine is cosine. And this brings us to our first trig identity that we are learning today, and that is sine of theta equals cosine of 90 minus theta. And similarly, because these are cofunctions, we can say cosine of theta equals sine of 90 minus theta. So these two are very, very important for you to know because they are cofunctions, but these are just the basics and probably review for most of you who have taken Algebra 2 and Geometry. And before we go, I just want to go over one trig function that maybe some of you may not know. Hopefully this will be something new for you and just not review. I will just delete these so we can this information so we can have some more room to write. Okay. So I want to go over another trig identity, and that is identity sine squared x plus cosine squared x equals 1. Sine squared x plus cosine squared x equals 1. So when we look at a right triangle, right, it will look like this. Let's say this is x. So then sine squared x, opposite over hypotenuse, so this is squared, plus cosine, which is adjacent over hypotenuse, equals 1. So we have this statement, and it would come to this: opposite squared plus adjacent squared over the hypotenuse squared equals to 1. Alright, so this is starting to look actually very familiar to a theorem we know, and I'll give you a hint. That theorem starts with a P, and it's named after a famous mathematician of the ancient times. And let's see what happens when we multiply by hypotenuse squared. Opposite, sorry, that's too small. Opposite squared plus adjacent squared equals hypotenuse squared. Wait up. This is exactly the same thing the same theorem we learned. We just have to replace opposite, adjacent, and hypotenuse with letters. Well, we know opposite and adjacent are legs, so that would be a squared plus b squared, and we know hypotenuse is seen as c in the Pythagorean theorem. So this is a proof of why this trig identity works. And I hope this video was useful and it was helpful for you to learn something new. I especially think the last part may have been something that was not taught in Algebra 2 and Geometry. So I hope you learned something new, and come again for next time, and we will hopefully learn some new things, and hopefully I will be able to explain to you in a way that's understandable. If not, please give some feedback. That's always a blessing, and thank you all.